Okay, this is the diagram that you should put in the middle of your head and stick it there someplace that it never comes out. And we'll take a little time about this because this is the basic principle. So the solid white line there, that's the soil surface. And the big picture, and just get my pointer here, the big that's old Sol doing its business. And down at the bottom we have the water table. Now the water table is where all pores of the soil are full of water. No air left. Up above here it can be a soil that's at the field capacity, which means that the fine pores are occupied with water and the coarse pores have been drained, and the coarse pores drain down to fill up the fine pores lower on the soil. And when it hits the water table, then of course what's going to happen, the water table comes up. So we have a water table that's close enough to the soil surface that this wick action can bring the salts and take them up. The old sun evaporates them and takes them off, and the salts are left behind. And that's the basic mechanism of soil salinization. It's too much salts, and the salts accumulate over time. And the salts can accumulate over time from relatively good quality water. In the Fielding area, Radisson area of Saskatchewan, there's an aquifer of some of the better water that's present in the ground anywhere in Saskatchewan. It's only about twice as mineralized of river water. It's only a few meters down, about 20 feet down in some of it. So over thousands and thousands of years, that water is pushing up, the sun is evaporating it, and it concentrates it at the soil surface. So some very good water in an aquifer underneath can end up with some very serious salinity at the soil surface. Now stop and think about this a minute. If you go away with nothing more today than this picture in your mind, you'll start putting that into how that fits into your situation. And you think about soil salinity and you think, well, it's more a dry country problem. We have it more in the brown soil zone, the Palliser Triangle. Yes, not as much in the black, we do have it. It's a brown soil, that's the main areas are arid climates. And it's caused by the evaporation. And evaporation is greater than precipitation. So if evaporation is greater than precipitation, how do we end up with a water table close to the soil surface? How do you end up with a water table close to a soil surface? That's where you have to stop and think about the problem. That means that you have to be moving water around underground to concentrate it in the place where you have the problem, and that's the key. So once you understand the principles, you will start putting it into context to your individual situation. Okay, so that's the fundamental thing. Like I say, if you go away with nothing more in your head but that, pointer off and we'll carry on. Okay, so